In the previous program, if you run it, you are going to see the output like this. So it means that for this Fahrenheit, this is the Celsius temperature. For this Fahrenheit, this is the Celsius temperature. Now if you observe it, actual value has to be something like 17.8. So these are the actual values which have to be printed. 17.8 and something is there, but then we are just truncating it to only one value there, right? So after the decimal point, we are just taking one value. Now if you observe it, there is a difference between these two, right? So this is the actual value and this is the truncated value, isn't it? So why did we get this one is because we have declared both the variables as integers, and now when we perform the division and multiplication, that was all about integer division and integer multiplication. So whenever you, as I told you, whenever you divide two integers, let us say 5 by 2, now if these two are declared as integers, right, for example this is a variable and this is a variable, and if these two are integers, then in the output you are just going to see 2, you are not going to see 2.5. now if you have to see 2.5 in the output, you have to declare them as floating point numbers, right? For that we have to use the type float. Now just to see this output, we are doing some modification here. Let's see this one. The code is modified here. Now where did we modify the code is, earlier FARH and Celsius were taken as integers, but now I am going to take it as float, okay? And now if you observe it here, when I am converting this Fahrenheit minus some number, this number is also given as a floating point number. 32 is an integer, 32.0 is a floating point number, right? And here also 5 by 9 was there earlier. Now we have taken it as 5.0, which is a floating point number, divided by 9.0, right? Now if you see this, finally it is going to be printed as percentile 3.0f and percentile 6.1f. It means that the value which is present in the Fahrenheit, the variable FAHR, has to be printed as a number like this. It has to be printed, it has to be taken as a floating point number only, because the variable itself is a floating point number, therefore it has to match up. And how do you want to print the floating point number is, you use 3 places to represent the number before the dot, and after the dot 0 places, which means you don't want to see anything after the floating point, okay? Only before the floating point you are going to see 0. Therefore how you will see the output as, now if 0 is there, it will simply be 0. Next 20 is there, it will simply be 20, right? After point there will be nothing. And finally if you have 300, it will simply be 300. Now it is as good as writing it as percentile D, but then you are not going to write percentile D here, that will give you an error. If you write percentile D and then if you have FAHR here, that will be an error. The reason is FAHR is declared as a floating point number, and so you have to use percentile F to interpret it correctly, right? And now see why it should happen is because while storing the value in FAHR, the format of floating point will be used, and now if you write it as percentile D, it will be interpreted as a decimal number, and therefore while converting that number, see the number is, when it is represented, okay, let us say there is a number 20.0, right? Now it will be represented in bits. Let us say this is some sequence which is used to represent some bits. Now when you are going to interpret it back, you have to use the same method which you have used here, isn't it? How you have converted this this number into a floating point and represent it. Now if you use a different way of interpreting it, right, let's say if you interpret it as a decimal number, then the value you get here might change. Maybe it will become something like this, okay? So that is the reason when you are declaring a variable as a floating point number, then while printing the values content which are present in it, you are supposed to use F. But then if you don't want to see after decimal point anything, if you want to print it just as a decimal number, then you can put .0. Then you are going to see a plain like this. Now, and the number of digits here will be a minimum 3, at least 3, which means there will be a blank space here, there will be 2 blank spaces here, right, and there will be blank space here like this. Now the next one is, let us say after this you want to give maybe some space, you can put \t, then you are going to see 4 blank spaces here, right? And after that percentile 6.1f, it means that whatever result you got which is present in this Celsius has to be displayed as a floating point number only, which will contain at least one digit after this floating point and then 6 digits before it, right? So it means that whatever value you get, let us say it is minus 17.8, that will be represented as 1, 2, 3 followed by minus 1, 7, which means 1, 2, 3, 4, 5, 6. So 6 digits will be used before this floating point, and then after this floating point 1 digit will be used. 6.1 means 1 digit will be used, and so 8, which means even though the number present in this particular variable is more than this one, let us say the number even is, if it is 812, that 12 will be truncated. That is the meaning of it. Got it? So this is how you can see that you can actually print the floating point numbers, and also you can print them to the precision you want depending on how much you want by using this float data type, right? So that is how we can use various data types. Okay, as we go along we shall see what are other data types available for us. Okay.